Now let's go ahead and model the pellets as well as the power pellets. So those are basically the dots which you see over there on the level. So I mean, since Pacman is a 2D game and because it was like very low resolution, we don't know how it was actually supposed to look. So what we can do is, for now we can just make a simple assumption. We'll create an actor and we'll just call it BP pellet. And I'll just drag this over here for now. I'll just move it slightly up. I'll just move it slightly up over there. We'll take a look at the placement later on. And I'll go ahead and create a cube. And for the scale, I'll just set it to some small value such as 0.2, 0.2, and 0.2. Now, what I'll do is I'll create a glowy material for it so that it illuminates. And just for extra visual effects, I'm just going to make it pulse rather than just stay at a constant emissivity. Go ahead and create a material and we'll call this one M underscore pellet. And we are going to apply this material. So I have this selected. I'll go back into pellet and I'll type in pellet over here. Alright. If I go ahead and compile it, you should get the default material. Now I'll open up M underscore pellet, and over here what I can do is I can grab a time node. Now this refers to the global time, so this value will keep changing actually. Actually, if you notice, this value will keep changing, so this is going to continuously change. And if you guys know the sine function, basically it's a function like this. So if I just open up one note over here and if I just grab an empty space, the graph for sine is going to be something like this. So it's going to be up, down, up, down. So what this is this is going to be a graph for some wave with some amplitude A, and this is going to be sine of some angle, so we can call this x. So actually it's going to be omega times t. So omega is going to be the angular frequency, but for our purposes we just care about the fact that it's pulsing, so we'll not really worry too much about the time period. So again, if you want, you can make use of the time period. I'll just keep it as is. So let's say, for example, so this is a sine wave. This is not exactly sine of x. This is a sine wave. And this is going to be time, and this is going to be a sine omega t. What we'll do is we'll use this as the intensity for our glow. If you would notice, actually, if you add a certain value to this wave, let's say we add a constant value. So let's say we add a constant, the wave is going to move up. So it's going to be something like this. And this is what we are looking for basically. Alright, so we'll grab the sine of this value. And I'll just multiply it a bit so that you can see the effect. And I'll just put that under the emissive color. And if I were to save this, you'll notice that you're actually getting something like this. But if you notice carefully, it is taking longer in the off section of the light. So if you observe, it's actually off for double the time that it is glowing. The reason is because of the sine wave. So when we directly give sine, we have a wave like this. So in this section, it's going to be glowing. But rather than starting to glow again, there will be a section over here where the light isn't actually going to glow. So whenever it's negative or 0, it will not glow. So what we have to do is we have to add some value. So over here, if I just add in some value, let's say I add in 1, because by default the amplitude is going to be 1. So if I add in 1 to the sine value, not to the multiplied value. So if I add in 1, what's going to happen is it's going to add 1 to the sine value. The maximum value of sine is going to be 1. Now, basically, if we assume the amplitude is 1, what we are going to do essentially is we are basically bringing it right here. So this is going to be 2 now. So this value is going to be 2. And we brought it right there. This multiply is just going to increase the intensity now. So now, if you would notice, we go to 0 and then it increases. if you want to, you can increase it slightly more. So let's say you make this 1.2. So it's always going to be glowing. So as you see, this is always going to be glowing. And I want it to be a little bit higher. So I'll make this 1.5 and I'll multiply this by 5. So if it's a little too much, we can reduce it. So I don't think it's too much. So I think this is appropriate. So I'm going to keep this as is. And we can just add in a color over here. So we can just add in a color. So since we have this multiply over here, we can multiply this itself by a color. So we can have a constant 3 vector. So if you type in con3, or if you just hit 3 on your keyboard, you're going to get that. And we can multiply this with this. So we can multiply this with the color. So let's say I make this yellow. And now if you multiply this, you would see that you're going to get the yellow pulsing. I have flux enabled, so I actually can't see the yellow. Now if I take a look, you see that it's glowing yellow. So I can make this a little more on the orange side. And if I want, I can reduce the intensity. So this is basically going to be our pellets. Let's just place a few more to see how it's going to look. So I have few pellets over here. So this is just for testing. We'll place them properly later. As you can see, the glow is actually synchronized and it's kind of pulsing due to that sine wave. Now for those of you who wanted to change the speed of this pulse, I'll just give you guys some hints on how to do it. So if you were to expand this sign, or actually if you take a look at the left side, you see a parameter called period. So the period is basically 1 over, the period is basically a time period and the frequency is basically 1 over the time period. So I'll just give you guys an idea. So over here, you have the angular frequency of this wave. So by default, so now let's talk about the output here. So after the multiply, I'm saying, so after this, so our amplitude is 5 because we multiplied the wave by 5. So it's going to be 5 sine and omega is going to be 2 pi times the frequency. So omega is going to be 2 pi times the frequency. Now that's not really important for us. We need it in terms of the period. So it's going, now frequency is going to be 1 over the time period. So it's going to be 2 pi over t. Now t over here is going to be 1. So 1 is the time period. So essentially, if you want your wave to pulse faster, you'll probably need to change this time. And you can just use a calculator to find out the sine value. So basically you have to change this capital T value. So as your T value increases, your omega is going to be smaller and your wave is going to be slower. So I'll just show you guys. So the wave is going to be faster is what I mean. So let's say I make this 10. So I increase the time period, so it's going to be slower now. So as you see, it looks almost the same. So if you notice, it's very slow. So it's going to take 10 seconds for the entire wave to finish. Just to tell you guys, for those who are not aware, so the point from, okay, I'll draw an actual sine wave. So let's say we have a wave like this. The time period between this and this point is going to be whatever period we are talking. So to cover 2 pi radians basically. So if we have period 10, so it's going to take 10 seconds to complete one whole cycle. That's going to be from here up until here. Alright. So 10 is a little too less. I was happy with 1 actually. You can make this 1 and now this is going to take 1 second to complete an entire cycle.